Where is the infinity in the circle?
Understanding infinity in the context of a circle. To grasp where infinity resides in a circle, when considering it as an infinite-sided polygon, let's systematically explore the concepts involved. 1. Defining infinity in this context. Infinity. In mathematics, infinity isn't a finite number, but a concept representing something without any limit. When we say a polygon has infinite sides, we're discussing a limiting process where the number of sides grows without bound. Limit concept. It's about observing what happens as the number of sides, n, of the polygon increases. Indefinitely, n approaches infinity. 2. Inscribed polygons approaching a circle. Inscribed regular polygon. A polygon where all vertices lie on the circle. As the number of sides increases, each side length decreases, the polygon's shape becomes increasingly indistinguishable from the circle. Let's consider regular polygons, where all sides and angles are equal. For simplicity, triangle, 3 sides, clearly doesn't resemble a circle. Square, 4 sides, still angular, but closer than a triangle. Pentagon, 5 sides, hexagon, 6 sides, etc. With each increase in sides, the polygon becomes more circular. As the number of sides, n, increases, the length of each side decreases. The internal angle at each vertex increases, approaching 180 degrees. The polygon's perimeter approaches the circumference of the circle. The area of the polygon approaches the area of the circle. The limit as n approaches infinity. Mathematically, we can express this as a limit. Let's denote the radius of the circle as r. A regular n-sided polygon inscribed in the circle will have each side length given by 2r sine pi over n. The perimeter p of the polygon is n2r sine pi over n. As n approaches infinity, sine pi over n can be approximated by pi over n, since for small angles, sine x approximately equals to x. So p is approximately equals to n times 2r times pi over n, which is equal to 2 pi r, the circumference of the circle. Infinity as a limiting behavior. No final polygon. There isn't an actual polygon with infinite sides. Instead, it's the idea that as sides increase endlessly, the polygon's properties, perimeter, area, become those of the circle. Smoothness from infinite sides. Finite polygons have corners, vertices. Infinite-sided polygons' corners are so frequent and slight that the curve is smooth everywhere. Practical implications and misconceptions. Not our real, infinite-sided shape. In reality, we can't draw a polygon with infinite sides. But mathematically, the limit allows us to equate the two. Circle's definition. A circle is all points at a fixed distance from the center. The infinite-sided polygon idea aligns because every point on the circle is a vertex of the limiting polygon. So, where is the infinity in the circle? The infinity in a circle, when viewed as an infinite-sided polygon, lies in the limit where the number of sides grows without bound. Specifically, in the sides, they become infinitely many and infinitely small, merging into a continuous curve. In the angles, the interior angles approach 180, making the shape smooth with no discernible vertices. In the measurements, the perimeter and area of the inscribed polygon converge exactly to the circle's circumference and area, respectively. Thus, the circle embodies the concept of infinity through this limiting process, where an endless increase in sides transforms a polygon into a perfect circle. Infinity isn't a tangible part of the circle, but is intrinsic to its definition as the limit of an infinite-sided polygon.
Thank you for watching. Like, share and subscribe.